Hi, in this video we're going to cover the alignment process of the TT200, which is a requirement in the commissioning process and maintenance intervals for the sensor. The tools required for this process are a laser alignment tool, a 485 comms cable, two 13mm spanners, and a PC for the software connection. The first stage of the process, the course adjustment, utilizes the laser tool. So first of all, we turn it on, insert it into the sight tube facing the mirror. With the alignment tool situated, the aim of this part of the process is to point the laser at the mirror on the other end of the bracket. We do this by adjusting the alignment studs using our 13mm spanners, one plane at a time. So first we would do the horizontal, then after completing the horizontal, we do the vertical. When making adjustments, it's also useful to slacken off the opposite stud. So first of all, we take a bit of the tension off. Then we make an adjustment with both nuts at the same time to move the bracket. The second part of the process, we're going to take the laser alignment tool and put it into the mirror end. At this stage, we're going to repeat the process at the mirror end, with the aim being to get the laser to be hitting in between all four of the lenses on the sensor head. Again, we do the vertical plane and the horizontal plane separate, and again, if we're going to make an adjustment, we loosen off the opposite alignment stud. Once the laser is aligned with the center of the lenses on the sensor head, we're going to remove it and put it back into the sight tube on the sensor head itself. The final stage of the course adjustment is to make sure that the laser is returning from the mirror back to its source, so bouncing back upon itself. Here you can see the laser returning from the mirror onto the laser alignment tool. The final stage of the course adjustment is to make sure we remove the laser alignment tool from the sight tube. This is going to allow us to have detector levels to do our fine adjustment at the second stage. The next stage is a fine adjustment. For this, you're going to need a PC connection, the TunnelTech software, which can be downloaded from our website, links are in description, a comms cable, and an understanding of which COM port has been assigned to that comms cable. Now we're going to connect the TT200 to the PC. With the comms cable connected, in Device Manager you should see a COM port assigned to the USB converter, in our case COM port 3. We now run the TunnelTech software and open standard version if set to CODEL protocol, or Modbus version if your analyzer is set to Modbus protocol. Once opened, you'll be presented with this page, which is the read function. First thing we need to do is we need to check our comms settings match up with the COM port assigned to the comms cable. To do this, you just click on a down arrow on the comms monitor, and if you need to make a change, tick unlock and select the COM port from the drop-down menu. We can quickly confirm communication just by clicking read once, and it'll load up a string of data. For the fine adjustment, the function we're interested in is the alignment function. Clicking read on this page will update the number, which we're going to use to align to. You must take care when selecting which instance to align to. In the case of a system that has an NO measurement, you always align to the NO channel. If there's no NO measurement, like a CO Viz monitor, you'd select the CO channel. If it's a Viz only, you select the Viz RX. Our instance, this system is a CO only monitor, so we're going to use the CO detector level to align to. And the whole purpose of the fine adjustment is to make adjustments on the alignment brackets as before, but in this circumstance, we're going to try and maximize the number displayed here on the alignment page. To do that, we can select an update rate of 3 seconds, click start, and now this system will be updating every 3 seconds so we can monitor the detector levels. When making the fine adjustment, to first gain an understanding of which direction to push the alignment in, you can use a small, what we call a push test on the tube. So if you put a small amount of pressure in one direction and then observe the detector levels, if they increase, that's the way you want to align the system to. Letting go of the tube should allow the detector level to reorientate and drop back down. Once you gain an understanding of which direction you want to line in, make sure that you only put small inputs in at this stage and also allow time to settle. So we're going to make a very small input on the alignment, and then we're going to wait 10 seconds for the system to settle to gain an understanding of which direction to go. There we can see we've had quite a large jump with only a small input on one side of the vertical alignment. We repeat this process going one plane at a time. So we go vertical, then horizontal, then vertical, then horizontal. The aim of the process is to maximize the number we see on the screen. So we're not aiming for any particular detector level. We're just making inputs on the alignment process until we maximize the number displayed on the screen. Once you've maximized the head end, then you repeat the process at the mirror end. Once you achieve the highest number you can on this plane, on the vertical, we can tighten up the opposite nuts again, and then we can repeat the process on the horizontal. So once we've achieved our maximum figure when during the fine alignment process, we now need to put the system into a zero calibration, because obviously any changes we've made to alignment will affect detector levels, and then detector levels will obviously affect the response of the system. Easiest way to calibrate this system is just to block the sight tube for about 10 seconds. So the system will see a drop off in detector level, it'll wait a certain amount of time, and then you'll hear a relay click to tell you it's gone into calibration. Just click then. We can double check that it's in calibration by going to the calibration function on the software. So if we just stop the auto update, and then from the function menu select calibration data, click read to do a single read, and you can see the current cal state down here is on. This calibration takes about 20 minutes and will automatically complete and go into measurement once we're finished. Final things we need to make sure, we're just going to disconnect the comms cable, and we're going to reinsert the plug so that we maintain the IP rating.